Hi everybody. This is just a little Mr. Fix-It kind of video. Now I had this charger. It was for a I better go grab the battery. It's for this nice battery for my battery-powered weed whacker. It's 18 volt. And I was charging it the other day. And all of a sudden, the charger just kind of shut off, and it was extraordinarily hot. Well, that was because I charged about 6 or 7 of these batteries in a row, because the same charger can be used for my old cordless drill, which I use more as a spare and backup, but that cordless drill also has a battery-powered circular saw, which I use quite often for cutting up pallets and whatnot, so I can go through 6 batteries in a row. Well, anyways, I overheated this little bugger and decided, well, since it's broke anyways, why not try and fix it? I was hoping that maybe just a diode or something had fried, but to my surprise, the solution was actually easier. I had power going to the transformer, but nothing coming out, that's the input, nothing coming out the back side. So I started pulling some of the protective tapes off of it, thinking maybe there's a scrape in the winding. Nothing on the board side. Yes, I did cut it off just because it was too hard to work with. Then I started pulling out the input side. Lo and behold, I find this nice tiny little fuse. Put my multimeter on it, and there's no continuity between. So, cut it off. And since I don't charge any batteries here without me being especially present, and considering this is a 30-minute fast charger, as all my high-powered chargers are, I don't care if this little fuse is on there or not. Plus, I know the reason why it went was because I charged too many batteries in a row and overheated it that way. So what I'm going to do is I'm going to connect the mains back up, solder it back on, tape it, then solder the input leads back onto the board, and we should have juice. I will combine my videos on this project into one long video, so I won't punish you guys with multiples, and we'll see if we can get this thing working again. Just don't forget you'll need lead or some sort of solder. Got my high-power soldering iron today, and a little electrical tape just to wrap things up, make it nice and clean. I suppose if you want, you could tape another fuse back in there. However, I can't even read what this one is. Supposedly this draws 60 watts from the 110 volt outlet side and puts out 18 volts at 1.3 amps. So, there you go. I really don't care if there's a fuse on there or not. So, see you in the next video. Actually, I'm going to be combining, so here we go. Well, apparently, that little fuse was the problem. Soldered that back together. Plug her in. Now we got I got it insulated too well. We got about 120 volts in, and we got about 22 volts AC coming out. So now I just got to attach these before I zap myself. Plug that. So now I got to reattach it to these 2 points, and since it's alternating current, it doesn't matter which one you attach to which space as long as it's thoroughly attached. And I might maybe have to attach it to the back side, because that's a stab through. Stab through is where there's a hole in there in the board. You stab the wire through, and then it gets soldered on the back side. And I am not spending that much time working on this, although hope you guys are enjoying it. I've been getting requests for videos, and actually, ironically, somebody else had a request similar, not quite, but similar to this. I'm working on a cordless drill power supply. Now, as long as you guys are watching, let me explain some of this just a little bit, what you're seeing here. Now, old nickel-cadmium batteries, drill batteries, chargers are usually in one of two forms. You either have a smart or semi-intelligent charger, which are usually also the fast chargers, and then you also have the ones that take a little longer, but you have to shut it off yourself when the battery's charged. The smart chargers usually shut themselves off. Now what you're seeing here, you connect up the alternating current to these two spaces. You see these 4 diodes there. That actually makes up oh, why am I going? I'm getting brain fart. Bridge rectifier. There we go. That is actually a open bridge rectifier. And actually, I can show you guys. Stop the video because splice them together is a pain in the butt. Oh, someone put a nice puddle of oil there for me. This is also a bridge rectifier. I order these from China. I usually get about 20 of them for $8, free shipping. This one's 50 amp, 1000 volts. So these are actually inside of here, and what they do is they fill it with a resin or an acrylic, seal it in. Nice thing about that then is you have an aluminum shell. Not only can you then bolt it to something, but you can also attach a heatsink to the back. On this device, we're not drawing enough power to warrant a heatsink, at least not under normal conditions. I have a habit of using everything I have to excess. That's why my Tesla's got 11,100 miles in 4 months, 1 week, and 1 day of ownership. And damn, I'm kicking myself for not getting a bigger battery. So, all right, back to the explanation. So what a bridge rectifier does is it takes alternating current and converts it into direct current, or DC current. And since a battery is DC current, AC comes in, out comes the DC. Here we have a capacitor. What that will do is that will smooth the current coming in, because once you rectify 60 hertz AC, out comes 120 hertz DC pulse, so a pulsating current in DC. And the capacitor will help, DC capacitor helps smooth that, so it's more of a steady flow, which of course direct current is supposed to be a steady flow, instead of pulsating. If any of you have ever watched my video series on building a capacitive battery charger, we actually leave the pulsating in, because my capacitive battery chargers for lead-acid batteries actually extend the life of the battery by reducing the sulfate buildup. Nickel-cadmium batteries do not sulfate. They grow what's called little whiskers inside the battery. I'm working on another video series for you guys on how to restore at least some of your capacity on a nickel-cadmium battery. Back to this. I know I get off track pretty easily. I'm not going to go through extensive details, but most of the high-speed charging batteries and smart batteries have a temperature probe. On the battery, that's usually the third unlabeled prong. Sometimes there's a little T. That would be here. That way, if the battery itself is getting too hot, because remember, heat kills batteries. That reduces the life of greatly reduces the life of lithium batteries, your lead-acid batteries, such as what's in your car, nickel metal hydride, and the nickel cadmiums, and that's why vehicles like the Tesla Model S have extensive cooling systems to keep the batteries cold. That's why vehicles like the Tesla can go hundreds of thousands of miles without the battery packs losing very much of their capacity. Whereas electric cars like the Nissan Leaf that use passive cooling, just whatever heat dissipates around it is how the heat gets dissipated. Those, in just a few years, are seeing significant drops in their overall capacity due to that. So that's why the high-speed ones have the temperature probe. Now your standard dumb chargers that you have to disconnect yourself, those usually charge at a much lower current or wattage. Like I said, this one's labeled as 60 watts, a maximum of 60 watts that it'll dump into your battery, whereas most of the dumb chargers I see are around 15 or less watts. Here's our little relay here. When the start button is pressed, relay clicks, allowing the power to flow to the positive and negative terminals. And that's your simple explanation. Because this one is a smart charger, there's your little chip right there that controls the actual charging process. And you have a number of diodes and resistors around. I'm guessing it pipes the power through the different diodes and resistors depending on how many watts it wants to dump into the battery. I'm not knowledgeable enough to get too much more detailed than that. Here we have it. I'm going to solder this transformer onto our board and put it back together and see if we have a working charger. Here we are, a moment of truth. Green light's on. Well, I hope you all enjoyed another how-to video. I know it wasn't none of my videos are quite the best creations. I do keep making these videos. A lot of them are based on viewer requests. So if you have a request, I kindly ask that you email me or leave it in the comment section, and I do my best to oblige. Now we have the Halloween season coming up, so actually based on commercial retail, we've skipped Halloween season and have gone straight to Christmas season. I prefer Halloween. It's a little more fun. But submit your requests. Helps keep my channel going. And don't forget to click the like button down there somewhere. And don't forget to subscribe.